Hi everyone, this is Mrs. Atkinson here, and today we are going to be reviewing for our Topic 11 test, which is tomorrow. Today is Wednesday, April 29th. All right, so you guys are really lucky because I'm actually using real problems from the actual test that you will see tomorrow. I'm sorry, tomorrow. So paying attention and watching this video from start to finish is going to be in your best interest. I'm going to be explaining some things that I think you may have a little bit of trouble on when you actually encounter the test tomorrow. So, this is problem number one on your test tomorrow. You're going to be looking at this line plot. It's called time spent completing a project. And you notice that there are hours and then there's dots above the amount of times that this number of hours was spent working on whatever project this was. The question says drag the times that are least common into the box. So we're taking these and we're dragging them into this box, doing it digitally. And then it says list the times that you drag into the box in order from least to greatest. So really there's two things here. We need to identify the times that are least common. So I'm looking up here. I notice that, 2 is a really common time, 2 hours. It has lots of dots above it, but the least common would be 1 and then 4 and then 4.5. Okay. And I'm going to drag them into the box in order from least to greatest. So the 1 would go first, right? Because 1 hour is the lowest amount of time. Then the 4, because 4 hours is the middle amount of time. And then 4.5, because that's the greatest amount of time. And so that's what it would look like drawn into those boxes. All right, let's take a look at item number 2 on the test. So number 2 is a pretty straightforward question. It shouldn't take you too much time. It says, if a line plot were used to represent this data set, how many dots would be placed above the 2? So you're simply counting the amount of times that the 2 appears in the data set and then selecting that choice. I'm not going to give away every answer. All right. This next question, item 3, is a data or a line plot showing the lengths of pine cones that Beth found when she went out on her walk. And it's asking for the most common length. So you're going to be looking at the numbers up here, and you're looking at these are the little dots are the actual pine cones. Which one was the most common length? You're going to find that, and that will be your answer, right? Whichever one has the most. Our next problem is, excuse me, I'm losing my voice. Too many video recordings. The next problem, let me erase this. I was using this before. This one is a multi-part problem. So you're going to have to use this same data set to do a few things. And I'm really wanting to draw your attention to this because there's probably a few different ways you can go about this kind of problem. It's giving you a data set and then it's asking you for the correct line plot. Two ways you can think about this. One, you can take the data and you can draw your own line plot. And then you can see which one of these choices matches the one that you drew. Or you can take this data set and look at these and kind of just try to figure out by process of elimination which ones are incorrect. And then in the end, you'd be left with the one that is correct. Either way is fine. Drawing your own line plot will take a lot longer, but it might be worth it in the end. So you're going to figure out which one is the correct line plot. The first thing I noticed, just to kind of help you out here, is that they all, like you could look at like where they start, and it looks like these three, D, C, and A, all start with 1 3/4. But look at B, that starts with a 2. So what you could do is look up here, is there actually a 1 3/4? And if I look, yes, there is. So I have to plot that data point. So this guy can't be the right answer, right? Because I don't have that point. So I don't think it's going to be B. So just kind of figure that out, which is the best answer. You might want to draw your own line plot just to be sure of that. Let's take a look at part B. How many more miles, how many more indicates subtraction, did the student who walked the greatest number of miles walk than the student who walked the least number of miles? So this is a subtraction problem, and you're going to have to subtract. Now, I just want to remind you, when you are confronted with a subtraction problem, let's just say, for example, it said 4 minus 1 3/4, because we do know that the greatest was either 4 1/4 or 4. Let's pretend it's just 4. I want to show you how we subtract like this. We have whole numbers in both of our and your parts, but this has a fractional part to the answer and this one doesn't. So we can't subtract 3/4 from nothing. So we have to regroup our 4. And so I'm going to pull 1 away from the 4, making it a 3. And then I'm going to take that whole that I pulled out and I'm going to think of it like 4/4. Why 4/4? Because our denominator over here is 4. So now I'm going to put that whole back in as 4/4, right? So 3 4/4 is just another way of saying 4, right? Here's 3, and then 4/4 is 1, so 3 plus 1 is 4. Now I can subtract, and I'll be able to get an answer. All right, and finally, part C. How many students walked at least 3 miles? Enter the number in the box. Now, at least means that they walked at minimum 3 miles. So they walked 3 miles or more. So you have to figure out how many dots are above the 3 plus all the ones above that, like 3 or more. How many students was that? You'll be counting dots. Moving on to question 5. Let's take a look. So here you're taking a look at lengths of pencils, right? I guess somebody measured them and they plotted some points. The little dots are representing the pencil itself. So you're just selecting here anything that's true. So like A, the longest pencil is 6 inches. Is the longest one 6? No, because the longest one seems like it's 7. So we would not be checking off A, right? The shortest pencil is 4 inches. I look up here, is that true? Yes. So I would be putting a check mark next to B. You can select as many of these as are true. So there can be more than one selected. For question number 6, we're talking about tickets sold by students. It says, Mrs. Boyd's class is tracking the number of tickets sold for the school carnival. The class goal is to sell 20 books of tickets. Each book contains 12 tickets. So I'm reading that, I'm thinking, I don't even know if they're going to ask this question, but if their goal is to sell 20 books of tickets and each book has 12 tickets in it, well, how many tickets is their actual goal? So I know that I can multiply 12 times 20 to find their goal in the amount of tickets instead of books. So I could use the cliffhanger method if I wanted. 2 times 2 is 4. 2 times 1 is 2. So their goal is to sell 240 tickets. That's their goal. All right, good to know. I don't even know if they're going to ask me that question, but whenever I see something like that, I just kind of want to process it in my head. All right, so here's my line plot and the first question. How many tickets have the students sold? Enter the number in the box. Well, let's see. This one is going to take some figuring out. I'm going to use this piece of paper here. All right, so let's see. These are the number of tickets and the dots are the students. So this says 2 students sold 4 tickets. So 4 plus 4, that would be 8. Okay. And then this is saying that 4 students sold 5 tickets. So this would be 5, 10, 15, 20. So that's 20 tickets. Add it to my 8 that I already have. 6, let's see. 3 students sold 6 tickets. So 3 times 6 is 18. Nobody sold 7 tickets. 1 student sold 8, so I could add an 8 onto that. 2 students sold 10, so that would be 20. 1 student sold 11, and then 1 student sold 13. So I would have to add all of this up. Oops, sorry. So I can break this down. I can try to make tens. I could do like 20 plus 20 is 40 and make smaller problems. But you're eventually going to have to get a sum of all of these. And then that is what is going to go here, the number of tickets. All right, let's see part B. Part B says, how many more tickets does the class need to sell to meet their goal? Oh, look, this is going to come in handy up here. So I am going to, this is their goal, 240 tickets, minus the answer to part A is going to get you your answer for part B. Question 7 is a pretty simple, I'm actually not even going to go over this. Okay. This is question 8. Mr. Rodriguez measured the lengths of lures in his tackle box. All right. I wanted to go over this question because of the word lures. Do you guys know what a lure is? A lure, you would know it if you fish. It's like, you could tell me if I'm wrong too. It's like a fake kind of fish or something bait that you would put on the end of your hook in fishing to lure the fish to want to take a bite so that you can catch them, right? Sometimes it's fake. It's like, it might look like little worm or it might be a brightly colored thing that the fish would be attracted to, but that's a lure. All right. So he's measuring his lures. Why he'd want to do that, I have no idea, but so be it. And this is what he got. So again, this is the type of problem where you have to match up the correct line plot with the data table. Personally, I would take the time and just sketch out my own line plot first and then see which one matches, just so I'm sure. Okay. And then comes along question 9. Now, question 9 actually has to do with question 8. I think this is the hardest question in the test. So you have to either go back to the correct line plot, and that's why it's so important that you get the answer right, because it's going to impact your answers for the next 4 problems, actually. So the greatest length is 2 inches more than the least length. So for that, you would do a little subtraction, and it's either going to be yes or no. Let's take a look at this one. Less than half the lures are at least 3 inches long. Now, half of the lures would be how much? All right, let's take a look again. How many lures does he have? Okay, let's see. He has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So he has 12 lures. So half would be 6, right? So they're saying less than 6 are at least 3 inches long. At least means they could be 3 inches or more. And the wording on this, I think, is the trickiest part of the entire test. So it's really important to make sure that you're trying to figure out yes or no to that. 1.5 is an outlier, yes or no. And finally, the number of lures greater than 2.5 is equal to the number of lures less than 2.5. So for that one, you're not counting 2.5. It's just either greater or less. All right. I hope that you guys do really, really well on your test. Please remember that this is your opportunity to show what you know. I highly recommend you taking your time using scrap paper and really just putting your every effort into it. Please do not get help from an adult. This is a grade that counts, and I really do want to see your work. All right, guys, good luck on your test tomorrow.